like to welcome everyone, students, families, faculty, and guests, to what I very much hope is the last physics department graduation ceremony that's virtual. I'm Chris Carone, the chair of the physics department. I've been a professor in the department for nearly 24 years and chair of the department for 4 years. I'll be the master of ceremonies for today's physics graduation presentation, which, like many of our classes this past year, is remote and asynchronous. Every year for the past 3 years, I've started my remarks with boilerplate material praising the faculty of the department as well as their research efforts. Basically, I've given academic infomercials. I'm not doing that this year. If that's what you're looking for, my 2020 commencement remarks are still up on YouTube, though unfortunately, if you click subscribe and tickle the like button, I don't get any financial kickbacks. This year, I will make one singular point about the unique value of your William & Mary physics education, but it will come rather circuitously toward the end of my remarks, so please bear with me. I usually base my parting words to our graduates on something that just happens to be on my mind when it's time to put this presentation together. This year is no different. Lately, I've been thinking about a memorable quote by the late Richard Feynman. Feynman was a Nobel Prize-winning theoretical physicist and one of the deepest thinkers of the 20th century. He said, I quote, "Never confuse education with intelligence. You can have a PhD and still be an idiot." Wow, that's harsh. Feynman, the man who was one of the founders of quantum electrodynamics, which is the relativistic quantum theory of electricity and magnetism, and who created the eponymous Feynman path integral formulation of quantum mechanics, suggests to our undergraduate degree recipients today that they could receive 2 additional degrees in physics, and some will still emerge as idiots by Feynman's definition. What was Professor Feynman thinking when he made this remark? Well, Feynman certainly was not implying that some could solve the Schrödinger equation properly while others might be inclined to get stuck. Feynman knew that a physics education will hone the basic tools of deductive thinking, of mathematical logic, and the unbiased evaluation of data as applied to questions of physics. What I think Feynman was suggesting is that a broader and consistent application of the same skills to other aspects of life is required before someone will escape Feynman's harsh assessment. Now, you may not have thought much about how your scientific skills might be generalized to, for example, your interpersonal relations or to ethical questions. So let me illustrate by giving an example and using the approach of another famous physicist, Galileo Galilei. Galileo would present a fictitious dialogue between 3 characters, Segredo, Simplicio, and Salviati, as a means of illustrating his scientific ideas, especially to a skeptical audience. Segredo struggled mightily to get through to the ever-misguided Simplicio, with Salviati playing the role of a pedagogical savior, just swooping in at the end with exactly the right arguments. My dialogue will be a little more lowbrow. We'll have 3 different characters, which we will assume all have PhDs. Dr. Fred Flintstone, Dr. Barney Rubble, and Dr. Richard Feynman, who I unceremoniously resurrect from the dead for this purpose. Now, if you're too young to have watched the Flintstones as a cartoon when you were a kid, ask your parents. They'll fill you in. Okay, so here goes. Fred and Barney have worked together for many years at a geological supply company in the city of Bedrock. Fred learns that Barney has just been fired for embezzlement, and the local district attorney has stated in a press conference that she has sufficient evidence to bring the matter before a grand jury. Fred is outraged and emotionally distraught. "Barney is a good man. I've known Barney for years. He's beloved at the company social events like our annual picnic, and he has one of the best sales records of anyone in the company," and on and on. While Fred is busy cursing the leadership of his company, Feynman on the sidelines is shaking his head in dismay, but ultimately, like Salviati, comes bounding to the rescue. "Dr. Flintstone," he interjects, "let's try studying this issue systematically. You assert that Barney is a man of integrity, he could not have embezzled," and Fred agrees. So Feynman continues. "So we can consider an experiment. A person's integrity can be judged by how they react when confronted with a choice between doing what's right and doing what's in one's self-interest when these 2 things are not overlapping. Do you agree that looking at such instances might shed some light on this matter?" And Fred again agrees. So Feynman goes on. "The experiment is retroactive since you've known Dr. Rubble for many years. So collect your data, analyze it, and tell me what you conclude from it." Fred, breaking out into a meat sweat, possibly from the Brontosaurus burger he had for lunch, begins reviewing his experiences and after some time arrives at a conclusion. Well, Feynman, it seems I don't have data that's directly relevant to the experiment you've posed. Fred's workplace encounters with Barney did not actually include any circumstances where Barney had to make a choice between what's right and what was in his self-interest when those two things were far apart. Although Fred admits his knee-jerk emotional reaction was unjustified, Feynman presses further with a necessary follow-up question. Then what, sir, led you to incorrectly categorize the data that you had? Well, only through logically rigorous and data-driven introspection will Fred realize that his reaction to the news about his coworker and his subsequent strained rationalizations were triggered by a subconscious desire to avoid a cognitive dissonance, one between a reality that a disinterested observer would not doubt, and an internal narrative that Fred found more comforting because it provided him with a sense of stability. So, the last part of our protagonist's inward application of scientific thinking is through his introspection and his personal growth. This theme, that scientific thinking should not be compartmentalized to scientific problems, has been part of all my recent graduation speeches to varying degree. I thought it was a pretty good theme, but alas, I learned it was not an original one. I discovered recently that these ideas were touched on by the Stoic philosophers of ancient Greece nearly 2,000 years ago. For example, Epictetus in the 1st century AD, and developed further by their counterparts in the Roman Empire, particularly Seneca, also in the 1st century AD, and Marcus Aurelius in the 2nd century AD. You see, Stoic ethics included the idea of, quote, living in accord with nature, unquote. This didn't refer to tree hugging. What it referred to is the fact that humans are endowed with the ability to reason, which they can apply both to understanding the manifest regularities of the physical world, like we do in physics, but also to achieving a virtuous and flourishing life. So, my message to the graduates today is simple. Please don't compartmentalize your scientific thinking. You are better placed than most to follow this advice, since your liberal arts training at William & Mary is what makes your physics degree special. It's second nature for you to seek applications of the methodology and thinking of one discipline to the problems of another discipline. My hope is that you will do this even more broadly, so that you, too, will live in accord with nature, and you may achieve a virtuous and flourishing life. Well, with my brief remarks out of the way, I would now like to turn to our official graduation speaker, Justin Stevens. Professor Stevens joined the physics department in 2016 after postdoctoral work at MIT and serving as a staff scientist at Jefferson Lab. Jefferson Lab is a major Department of Energy national laboratory. It's 20 minutes away from campus in Newport News, and many of our faculty do research there. Justin is currently an assistant professor, which means he does not have tenure, and so he couldn't refuse my request to speak at our ceremony today. Professor Stevens' work in experimental nuclear physics has focused on studies of exotic particles that are predicted by our theory of the strong nuclear force, which is the force that holds the nuclei of atoms together. It is with great pleasure that I introduce Professor Justin Stevens.
Good afternoon, and welcome to the virtual physics department commencement. I'm Justin Stevens. I'm an assistant professor in the department, and I was asked to say a few words to this year's graduating class. Now, it's obviously an understatement to say that this past year has been challenging, and you as the graduating class of 2021 have had a truly unique experience this last year and a half. Whether you were in person or learning entirely remotely this past year, completing your physics degree during a global pandemic is an achievement that should truly be celebrated. So let me begin, as many already have, by congratulating you on this achievement with some virtual applause, as we've done so many times this year over Zoom. Now, in looking back at your time at William & Mary, it may be tempting to remember challenges of working on problem sets late into the night, sometimes the wee hours of the morning, or writing the nth lab report for the semester. And while we as scientists and physicists in particular can sometimes get lost in these details of the calculations or the studies we're working on, let me try to give you some context for the broader world of physics during your time here. So shortly before many of you arrived at William & Mary, there was a major discovery in astrophysics, where gravitational waves created by a pair of spiraling black holes were observed by a collaboration called LIGO. This discovery required tremendous technological achievements where those gravitational waves that were causing changes on the length of a 2.5 meter long laser cavity had to be measured to an accuracy of 10 to the minus 16 centimeters. Now, I met many of you in experimental atomic physics during your second year at William & Mary, where we couldn't build LIGO, but we could make a miniature version of this interferometer experiment that allowed us to look at the interference between laser light with a similar setup of 2 spectrometer arms. And you could get some perspective on how challenging such a measurement might be. Now, while you were toiling away in courses like quantum mechanics and electricity and magnetism and completing your senior thesis projects, there have been many more grand achievements over the last several years. For one, the Event Horizon Telescope provided us with our first image of a supermassive black hole at the center of a nearby galaxy. And recently, many of you have probably read in the news of NASA's landing of a new rover on Mars, which flew a small drone on another planet for the first time. And there are many more that I don't have time to list today involving our students and faculty here at William & Mary doing groundbreaking research. Now, I remind you of all these tremendous scientific achievements because each of them is not a single event, but a culmination of decades of effort with countless students like yourselves, faculty like me, and scientists from often around the world working tirelessly on a common goal. In your research studies at William & Mary, you may have studied ultra-cold atoms in the basement of Small Hall, or analyzed nuclear physics data from experiments at nearby Jefferson Lab, or developed new technologies in our engineering physics and applied design program. But in all those, you have developed firsthand experience on how challenging and yet how rewarding this kind of research can be. You've all made really meaningful contributions to this scientific endeavor, which requires lots of small incremental steps, which turn into progress that eventually results in breakthroughs. And this is what makes it into the news media. So we thank you for those contributions and really congratulate you on those efforts in this endeavor. So let me close with a few thoughts on your role as newly minted physics graduates and how that might impact how things look for you going forward. So if you weren't already, you are likely now the scientific expert among your friends and family. And quite soon you'll have the credentials to prove it. This comes with lots of benefits, like being in on all the inside jokes and memes and science puns that most people don't get. Parents and friends, don't worry, you can ask your graduates to explain this one to you later. You can also knowingly laugh anytime you see a new product that tries to sound impressive by adding the word quantum to the brand name, because you know what quantum really means. But you also have some new responsibilities, which include being the expert in the room to explain why we need and should listen to scientific expertise on many of the challenging problems in the world today, ranging from battling COVID to climate change and many more. Now, recently we were reminded in a departmental colloquium that one of the first Zoom calls took place 40 years ago last week, where 2 national laboratories in California needed a video conferencing system to collaborate on a particle physics project. Now, this conferencing system wasn't the fundamental goal of the research, but it was a byproduct of pursuing the fundamental research where they developed a technology that they needed. Now, little did we know that in 2020, similar technology would enable the continuation of some semblance of life during the global pandemic. So with this in mind, and the ability of physicists to develop new technologies as needed, we look forward to the new discoveries and technologies that you'll develop in your newfound careers, whether that's continuing your studies in graduate school or working at a new tech startup or anything in between. Who knows what discoveries you'll make along the way, and what impact that might have on all of us down the road. So on behalf of the faculty and the physics department of William & Mary, I'd like to thank you for all your contributions to the department while you've been here, and congratulations again to the class of 2021.
Before reading the names of our degree recipients, I would like to recognize those students who received academic awards or prizes earlier this year or last year. I'll first describe each award and then name the recipient. The 2021 Physics Undergraduate Research Prize, to be awarded to the senior or seniors with the highest demonstrated achievement in physics research. Performance in classes will not be a criterion. Awarded in the spring semester requires one letter of recommendation, typically from the research supervisor. This year, the Undergraduate Research Prize is shared between Austin Batts and Daniel Slyepichev. Congratulations, Austin and Daniel. The 2021 Don Edward Harrison Jr. Award for Excellence in Physics, to be awarded to the senior with the highest demonstrated achievement in physics. The selection will be made by the undergraduate committee at the end of the fall semester, based on the entire academic record, the preliminary oral and written presentations of the senior research project, and 2 letters of recommendation. This year's winner was Stuart Thomas. Congratulations, Stuart. Next, the 2020 Frank Hole Memorial Physics Award, to be awarded to a physics major in the spring for excellence in research performed prior to the senior year. Requires 1 letter of recommendation, typically from the research supervisor. This award went to Finn Mayhew, who is receiving a degree today. Congratulations, Finn. Finally, for our undergraduate awards, we have the 2020 E.G. Clark Memorial Scholarship, an annual scholarship to a rising senior with a concentration in physics who has demonstrated an outstanding aptitude for the study of physics, and the award requires 2 letters of recommendation. That award went in 2020 to Stuart Thomas, who is receiving a degree today. Congratulations, Stuart. Last but not least, we have a graduate student award, the Rolf G. Winter Teaching Award, offered annually to the graduate student in physics who has demonstrated dedication and excellence in the performance of his or her teaching responsibilities. This award in 2015 went to Andrew Peter Rotuno, who is receiving a degree today. Congratulations, Andrew. I will now read the names of the graduate students who have received the degree of Master of Science in Physics. Justin Camarada. Nicholas Casey DeStefano. Catherine Taylor Evans. Ziki Niu. Yiki Yang. William Henry Miyahira. Lydia Ellen Laurenti. I will now read the names of the graduate students who've received the degree of PhD in physics or are expected to receive the degree in the near future. I'll give their name, their advisor name, and their thesis title. Denise Erin McKegg. Advisors, DeLoss and Cook. Quantitative analysis of EKG and blood pressure waveforms. Shongli Du. Advisor, Aubin. AC and DC Zeeman interferometric sensing with ultracold trapped atoms on chip. Christopher Thomas Johnson. Advisor, Dudek. Excited J-, resonances in meson-meson scattering from lattice QCD. Andrew Peter Rotuno. Advisor, Aubin. Radio frequency AC Zeeman trapping of neutral atoms. Timothy Barton Hayward. Advisor, Griffioon. Dihadron beam spin asymmetries on an unpolarized hydrogen target with class 12. Colin Paul Eggerer. Advisors, Richards and Orginos. Forward and off-forward parton distributions from lattice QCD. David James Lenneman. Advisor, Kesselbosch. Light-matter interactions in quasi-two-dimensional geometries. I will now read the names of our undergraduate degree recipients, which is based on information available at the time of this recording. I will also include the advisor name and the title of each student's senior thesis. Rodrigo Vidal Arias. BS in Physics, EPAD track, with a double major in Global Studies. Advisor, Nelson. Thesis title, Glubot. Brett Hudson Barth. BS in Physics, Advisor, Kordosky. Studies of neutrino interactions and neutrino flux using the Dune near detector. Austin Hosea Batts. BS in Physics with a double major in Math. Honors and Phi Beta Kappa. Advisor, Ehrlich. Composite gravity in curved spacetime. Andrew John Belling. BS in Physics, Honors, and Phi Beta Kappa. Advisor, Aubin. Progress towards electromagnetic manipulation and trapping of microparticles. Michael Brennan Brown. BS in Physics. Advisor, Cook. Development of a high-voltage Marx generator for plasma immersion ion implantation. Lauren Marie Carver. BS in Physics. Honors. Advisor, Armstrong. Simulation and optimization of kinematics measurements for the Muller parity-violating electron-electron scattering experiment. Samantha Lee Cahodas. BS in Physics. Monroe Scholar. Advisor, Cook. Development and characterization of outgassing rates for use in an expanded LIGO vacuum. Giles Thompson Rex Corzine. BS in Physics. EPAD track. Advisor, Fry. Development of advanced additive manufacturing for piezoelectric polymers. Simon James Davenport. BS in Physics, EPAD track. Advisors, Cook and Fry. Breakout board process research. Jonathan Toniel Diaz Ramos. BS in Physics. Advisor, Novikova. Development of a tunable microwave source for EIT magnetometer. Jackson Bernard Dillard. BS in Physics with a double major in Math. Monroe Scholar. Advisor, Ehrlich. Non-locality in a stochastic approach to quantum mechanics and quantum field theory. Christopher Scott Egerstrom. BS in Physics EPAD track with a double major in Math. Monroe Scholar. Advisor, Fry. Development of advanced additive manufacturing for piezoelectric polymers. Cutter, Lake, Fugget. BS in Physics EPAD track. Advisor, Cook and Fry. Breakout board process research. Malay Tesfayohannes Haddis. BS in Interdisciplinary Studies. Advisor, Cook. Development of step-up device for senior citizens. Adam Gray Hainberg. BS in Physics Pre-Med track. Advisor, Cotan. Structural and orientational characterization of host defense peptides via solid-state NMR and oriented proton chemical shifts. Ali Abdelnasser Hassan. BS in Physics, EPAD track. Advisor, Cook. Development of step-up device for senior citizens. Gabrielle Rebecca Jauer. BS in Physics, EPAD track. Monroe Scholar. Advisor, Cook. Development of step-up device for senior citizens. Finian Ramsey Mayhew. BS in Physics with a double major in Music. Advisor, Volley. Studies of beamline instrumentation in the NOVA test beam experiment. Combe Thomas McDermott Jr. BS in Physics, EPAD track. Advisor, Cook. Bluetooth low energy connection via mobile application. Preston Crowell Mulford. BS in Physics. Advisor, Orginos. Testing magnetic Hamiltonian Monte Carlo on the Sine-Gordon model. Douglas Joseph Palumbo. BS in Physics, EPAD track, the double major in History. Honors, Mortarboard, Phi Beta Kappa, and Monroe Scholar. Advisor, Jeffrey Nelson. Machine construction and end effector iteration of Fermilab Dune's anode plane assembly epoxy printer. Jonathan Lawrence Palumbo. BS in Physics, EPAD track with a double major in History. Honors, Mortarboard, Phi Beta Kappa, and Monroe Scholar. Advisor, Yang. Preclinical development of a smart video laryngoscope. Elizabeth Ann Salata. BS in Physics, the double major in Math. Honors. Advisor, Stevens. Exploring the Phi Eta Prime final state at GluX. Daniel Oleg Slyapichev. BS in Physics, EPAD track. Advisor, Yang. Preclinical development of a smart video laryngoscope. Stuart Nathan Thomas, BS in Physics, Honors, Phi Beta Kappa, 1693 Scholar and Monroe Scholar. Advisor, Monahan. Topology of the O3 nonlinear sigma model under the gradient flow. Jacob Thomas Wacht, BS in Physics, EPAD track. Advisors, Nelson and Harris. Characterization of water column structure in the northern Andaman Sea, Myanmar, based on field data collected in December 2017. Maximilian Sellers Weinhold, BS in Psychological Sciences with a double major in Physics, EPAD track. Advisors, Cook and Fry. Breakout Board Process Research. Doyle Stevens Weishar, BS in Physics, EPAD track. Monroe Scholar. Advisor, Fry. Development of advanced additive manufacturing for piezoelectric polymers.
Congratulations, class of 2021. You can be proud of your many accomplishments, all the way from Physics 101 to weathering the trials and tribulations of senior research. You have survived and thrived in a global pandemic, and many of you can even say that you've survived quantum at 8 a.m. with Armstrong. I'm not sure which is more impressive. Well, I hope to see you again sometime soon when we don't have to be socially distanced and wear masks, and welcome you back to William and Mary. Always view Small Hall as a second home in the physics department. Congratulations again.
Hi, Andrew. How's it going? We wish you a very happy graduation and good luck with your career in the future, what comes next, both over the summer and in the longer term. And it's really been a pleasure to have you here in the lab, and we look forward to hearing about your future adventures and accomplishments.
Andrew, it was wonderful working in the lab with you when we could. Goodbye and good luck. It was a pleasure.
Hey, Andrew. I'm really happy to work with you in the lab, and congratulations for your graduation, and good luck for your future career. Yeah, see ya.
Andrew, great having you in the lab, and best of luck in the future.
All right. Bye, Andrew. Good luck, and hope to hear from you.
Congratulations, class of 2021. You've made it through the year, through the pandemic year on your senior project of all things. So that's got to be the hardest time ever for physics majors. But you guys made it through, and made it through in terrific shape. I know that because I've taught many of you E&M back a couple of years ago. But the students that I know best are the ones who worked for me this year, and I want to give them a special shout out. Samantha, who has been helping me figure out what it is that we get when we think we're trying to get a vacuum. Brennan, who's taken my lab to a whole higher level by cranking up the output on our pulse generators. And then the people from EPAD, in particular both teams, the Step Up team, who's been making wearable sensors that tell you how you walk, and that's G, Ali, and Melee, along with actually Calm, who also worked during the fall, making that whole device be able to be loaded onto your phone, at least the output from it anyway. And then the chairman of the boards, Max, Cutter, and Simon, who have been working hard all year trying to make it a process so that anybody can create their own circuit boards. We expect you'll be using other students will be using those in the electronics course in years to come, and maybe they'll thank you for the extra work, and maybe not. In any case, you're a terrific class. Congratulations. I hope that your future is as bright as your past was these last 4 years at William & Mary. Thank you for all your work.
Holy crap, you're finished? You're done? No more William and Mary in your future? Well, that's not quite true. You're part of the tribe now. Once you're part of the tribe, you're always part of the tribe. So William and Mary might be your alma mater now, but you are part of William and Mary's history, and you always will be. So congratulations. I'm proud of all that you were able to accomplish, especially in these last crazy 14 months. Lots of hurdles were thrown at you, and you got through all of them. So congratulations, and I wish you well in the future.
Dear students, congratulations, you made it. It's custom to wish a luck in your future paths, but I think you don't need a luck. You have all the training you might require and you're fully prepared, so your future is bright, you will make it. I hope to see you around in following years, so come and visit us, we will be happy to see you. Goodbye and best of luck.
Congratulations, seniors. I am so impressed and really proud of how you've completed your undergraduate degrees in such difficult circumstances. I think it's a remarkable testament to your hard work and to all of your talents. And I think it augurs well for your future successes, and I can't wait to hear all about them. I hope that you look back on your time in William and Mary and in the physics department in particular with good memories, in spite of everything that's happened over the last 18 months. And in particular, for those of you that took quantum mechanics with me, I hope you look back and remember some of your quantum mechanics too. Have a wonderful summer and enjoy your well-earned rest. Congratulations again, seniors.
Dear graduates, it really feels like only yesterday I had many of you on my modern physics class and dazzling with you with the relativity and quantum mechanics, and now we have to say goodbye. I will really miss you guys. I think everybody hopes that all our students have memorable and unique college experience, and you definitely hit the high point on that one. But I hope that you will have a lot of not only COVID-related memory, but also the memory of fun homeworks and exams, maybe classes, connecting with people, learning more about the horizon of physics and science. And I'm really hoping to see you all here in 1, 2, 5, 10, 20 years. I'm not sure how long I'm going to be here, to come back and tell you how you've done. A special shout out for SPS and its amazing leadership, not only because I'm SPS advisor, but also because I connected to many of you guys through SPS and our outreach activities. I will really miss you, and I think together we did really nice things with Physics Fest and the school visits and so on. So I hope you will come to Physics Fest now as a guest to enjoy it. Again, congratulations you all, and best wishes.
Congratulations, class of 2021. Folks that took my electronics courses, I was so happy, and so you guys didn't even want to leave after we finished our final project together and hanging in the hallway. For Jonathan, Daniel, and Des, thank you. Thank you for this year-long journey with me. The only word I can really say right now is amazing. You already know it. Des, I'm sorry that your name was not read in the ceremony due to late paperwork. Please pursue your dreams. Anyway, congratulations again. Good job. Wow, amazing.
Congratulations to all the graduates. This concludes the Physics Department's virtual graduation ceremony. I wish you all the best of success in your post-William Mary era, and hope that you'll stay in touch so that we can take pride in your accomplishments in the future.